Hey, and welcome to this session of Show Off Your CI/CD. In today's session, I'm joined by AJ. Hey, AJ, great to see you.
Hi, Jones. Happy to see you.
You have a cool hat, my friend.
Yeah, it's a recently got a swag from the Amazon for the community builder. It's good to be on the good community.
Yeah, and that's actually how we met. I'm also wearing my T-shirt, which I got last year. So it's a pleasure to have you on today. Where are you joining us from?
I'm currently joining from India. Okay, it's evening here. And hope it's AM there. Correct. It's
No,
almost
it's almost 5 p.m. for me. So I'm in Germany. So it's 5 p.m. And yeah, has been a great day so far. And I'm really excited for today's session as you're going to teach me something I've not done before, to be honest. So I've not been exposed to anything in regards to machine learning. And I heard that you run a user group in Bangalore, which is focused on machine learning and data. Is that correct?
Yeah, sure. Yeah, I started a user group, AWS Data User Group Bangalore, and I'm currently also active in AWS User Group Bangalore also. And we take a session on multiple topics revolving around AI, ML. Recently, couple of session on the generative AI. It's good, okay. And definitely thanks, Jones, for giving this opportunity to talk to you. And as you said, it's a wonderful platform being connected with the AWS Community Builder. We can meet the great minds with a great enthusiasm to share the knowledge.
Yeah, I can only second that. What are we going to look at today?
Today, we are going to talk about how the life of the machine learning operation engineer or ML engineer. Everybody talking about fancy about the machine learning model, everything, but the real value of the machine learning comes how we productionalize the model and how it work at the enterprise scale. Okay, so AWS has a lot of fantastic tool, but you need to understand the complete life cycle and what are the best tools available in AWS to make your life easier.
Yeah, and I personally just, if I hear about ML, I'm always saying like, oh, this is kind of too big for me, right? So that's why I propose that we're going to start very slow on the ML topic, as this is new for me. So we're planning to record 2 sessions. The first one today is hopefully focused a little bit on things that I can understand, provisioning the infrastructure pieces. And then we're going to look a little bit details into the ML ops engineers' work at the end, the ML data scientists' work at the end, how you deal with the data that is then actually being done on top of that infrastructure. So that is the plan for our 2 sessions. Really looking forward to it. And I would propose we just dive into it, right? So let's move ahead, start sharing the screen, and then let's look at how we get the infrastructure up and running.
Definitely. Let me share my screen. Give me a minute. So I'm on my bigger screen. So I'm going to be, let me know if it is
It is perfectly visible.
best. Okay. So let's go back. Okay. So machine learning life cycle. As we this is a machine learning or ML ops come out from the practice of the DevOps. They found there is a good practice on the development and operation team working together in a cohesive manner and brought a lot of value to it. So they want to adapt the best practice of the machine learning team also adapt the same practice to work with operation to efficiently productionalize the model and bring a value for the machine learning. That's where the ML ops came to the picture. Before diving into the ML ops, as anybody in the organization who is working in any technical field need to understand the machine learning life cycle. And machine learning is not about the model and everything. Okay, model is a tiny piece. Okay, I could have shown some diagram where the Google released on 2014. The machine learning code is the center part, which is a very tiny part, but a lot of other components involved. Name it. Everything starts with the data and how is your infrastructure scalable, and with how the model monitoring work, how the complete CI/CD into the place where we adapted best practice from the DevOps. These are all pivotal a pivotal component needed for the successful machine learning project. So let's dive into the high level logical architecture or logical component how this ML lifecycle increased. It's all start with the problem statement, and not all the problems are machine learning problem. sometimes a rule engine works better. There is no need for the machine learning at all. So as a machine learning engineer, it's a very important decision to work at the first step. Is it really machine learning problem, or is it something you can handle in a rule engine? The
Mm-hmm.
second thing, we need to gather all the data. Okay, you will be a fantastic data scientist, but if you don't have a data, you cannot train the model. Okay, so it's very important. You need to have enough data. You take any use cases, you need to have enough data. Let's say you want to do the sales prediction for the company, which lasted for 20 years. It is easy to take the data and predict. But if the company started last 2 months, and if you say what is a prediction, then it doesn't make any sense. So that's I just giving an example of what is needed for the data. So after getting the data, you need to understand the data. Let's say if you are taking a sales, you may have a different information, a product ID, where we are selling, whom we are selling, latitude, longitude, when we are. So each we call it as a future. And we set a baseline. Okay, this is the data, this is the baseline, this is the accuracy I'm expecting. If it is 100% accuracy, your model is perfectly wrong. Okay. So the best thing the model can do is generalize. It need to be generalized the new novel input. So once you get your data, then you identify the model. There are flurry of model available. In AWS, there is a pre-defined, pre-built model or sample models available in AWS SageMaker Jumpstart. You no need to do any undifferentiated heavy lifting. You can go check on the already built the use cases and the notebooks available. You understand that and you plug in the data, then you are good to go. So you train your model using a training data. Always, if you have a set of data, 80-20 or 70-30, you split
Mm-hmm.
your data and you train the model and evolve the model with the other part and see how your accuracy is. If your accuracy is bad, then it is not a model. And you need to think, is it a model problem or data problem? If it is a data problem, go back, get more data and train. Then you need to understand whether this model need to go as a real time. Some you have front end application where you get an input and it give a real time output, yes or
Mm-hmm.
no. So is it it's a real time inference. Sometimes you have a model which can be batch processing. Okay, it will get the data, it process, it correct the data, keep the data in S3 or keep the data into any of your Athena or okay. So that is a batch processing. So you need to different you based on your business requirement, you need to do it. And if it is a real time inference, very important whether you are able to serve in a better throughput. It's not like customer send for a payload and you will send after 2 minutes. The very important for the real time inference is throughput, low latency, and all the new data you are collecting. Always you need to store those novel data and use that data and train it again. Okay, there are a lot of pieces we can put together, but as a beginner or any infrastructure guy or any developer who want to use a machine learning service, this is a baseline they need to understand. Problem statement, data, and you are doing the model cycle. Hope
But
this would have given, it will not scare you, could have given you some good kickstart.
it gives me a good sense of how this ML thing is going to work at the end, right? But what I did not really understand so far is how do we get where do we get this to run? So I'm used to a world where writing infrastructure as code in something like CloudFormation or CDK or Terraform is what I want to achieve. Now, how do I do that here? Can I provision the required resources in the same way, or is there a specific concept that I need to keep in mind?
Yeah, definitely we will go understand what AWS provided as a pre-built. The best part about the AWS, right? They give, take it, this is a foundation, you build on top of it. Okay, and they will help you on a kickstart where you no need to juggle around. We are going to check that one. Before going there, very important, right? In organization structure, there will be different personas available. Okay, somebody a project manager, somebody a machine learning engineer, somebody be a data scientist, somebody a data engineer, because here are a lot of personas involved. Okay, we need to understand what are the resources each team may be working on. That's what I want to talk about on the next session. Next slide. So here, right, everything we need to start at the fundamental.
This is something that I know. There's the icons, right? The stuff that I'm keen to see.
Okay, so let's go from the top. It's all comes from the business value, right? So you given a fantastic data. Okay, you predicted the model with the batch processing and keeping the data in S3. So the business people want to take a value out of it. What you can do, you can create Athena, and on top of Athena, you can connect the quick sites and take the report. Okay, and this is at the top level. But at the same time, let's go to the top down. You need to have fundamental architecture. You can build a complete cloud formation template in a complete stack set according to our organization standards and publish as a service catalog. And from the service catalog, you can publish to the different accounts where the team will be operated. And you can have a common, you definitely need a model monitoring. So you need a CloudWatch. And if it is a real-time inference, of course, you need a API gateway and all the foundation component, IAM, KMS. These are all handled by the IT lead team. Okay, they give you the service catalog where you build a template and give this template to them to service catalog and publish to the target account. That the uh, IT lead will work on that layer.
Okay, so let me ask one or two questions just to ensure that I got this right. Everything that comes below SageMaker and Code Commit and Amazon EMR and Service Catalog, this is stuff that is provisioned using infrastructure as code, is what you're saying? Is that correct?
Yes, right. This component, right? So the component second layer where the EMR, Athena, Glue, Lake Formation, these are all where the data platform engineer, the data engineer work. Okay. And the best practices is you need to provision everything via code. You can use your choice of the tool. If you are want to be agnostic, you can use a Terraform to provision your EMR cluster, and you have to provision. You can provision Athena, Glue, everything you can provision via Terraform. But I have seen the infrastructure people provision everything via standard CDK. They can keep their CDK in S3 bucket, and whenever they need, they call via Lambda function and create it on the fly. Because these are all, except the Athena, the EMR recently announced a serverless. Previously, EMR run on the nodes, where sometimes if you're not using, it is going to cost a lot. Okay. So the best practices is infrastructure as a code and run when it needed, and keep the data always on S3.
Okay. So that's kind of what I now understand a little bit. So there's a lot of stuff in this architecture that we can automatically provision using a normal CI/CD pipeline. This is all of the base infrastructure that we have. But then there is one or two pieces where we need to have someone actually interacting with that model, right? So what I hear is, like, I would assume that that's in the notebooks and that's in QuickSight, right? Or is there something else where you need manual involvement in setting this up?
Okay, so the SageMaker notebook, I have seen the infrastructure. Currently, AWS came up with this SageMaker Studio lab. And the reason for this lab, it has a reason, right? It came with the iterative process. Previously, they gave a standard notebook template, but it not had any authentication layer. I say it cannot integrate it with the company or IDP. Okay, so you cannot integrate with the AD or something. The recent Studio SageMaker domain, it integrated with the Active Directory, and everybody in the company can have a separate notebook, which we have provisioned before using a Terraform. Every individual, we will create a proper profile, proper IAM role on what S3 bucket they can access, and what privileges they can access to the EMR, whether they invoke the Lambda function, which invoke the EMR, and which Lambda function we can invoke where we already orchestrated the configuration for the EMR as a SDK. So everything we have done in a Terraform and provision. I even have in my GitHub notebook how you can provision the SageMaker domain using a Terraform. That's the best practices. The SageMaker domain notebook can, once it's provisioned with the infrastructure as a code, the other point, the complete SageMaker MLOps can be done using a predefined templates, okay, which AWS has provided as part of the projects, which we are going to be seeing in the next session. The very important thing I want to take away from this slide is we have involved multiple personas here. Okay, we have business analyst, data scientist, and ML engineer, data engineer, they all work in a different component, a different layer. But everywhere the best practices is to use the infrastructure as a code. And we have, before coming to the SageMaker on 2017, we have done a complete ML ops, ML orchestration on the step function, wrote on the SAM template. Is that you go collect the data from this, you pass the data, one more Lambda function, and then one more batch process. Then we have a Fargate container, we deploy as everything. So that was there, okay. But AWS made the life simple, okay. So the complete step function, we use a SAM template before, okay. So yeah, it's always good to go infrastructure as a code where you can have a reuse, okay. It's a plugin, okay. We have new developer come in, they can check the code, they can understand, okay, this is what I need to make a changes. I go ahead and make it. So that's the power of the proper DevOps practices we can adapt it in MLOps.
Okay, cool. That's really insightful, at least for me, as I'm learning a lot. Now, let's take a step back and do a short summary as we are approaching the end of the first part. And for that, please stop sharing your screen. So let's try to summarize. Or let's say I'm going to try to give it a go and try to summarize what I learned. Right. So for me, what I'm taking away from the first part of our session is that in the machine learning space, it's very important to keep in mind the business case that you're trying to reach with the ML stuff that you're building. So with the machine learning stuff that you're actually building. This means that you need to take the business in front of anything that you start building out. This will be very important for your success of your project. I've also taken away that the CI/CD concepts for infrastructure that we have for serverless projects or also for other kinds of the projects, they apply seamlessly to ML workloads, because most of the machine learning components that we require can also be provisioned using CloudFormation, Terraform, CDK, or Pulumi or something like that. So the same concepts from a CI/CD perspective apply. And this then enables the machine learning engineer, the data engineer, to start testing models and start gaining experience with how they can solve the business case that we started the project with. Yes. That's my takeaway. Did I capture the most important things?
You are right. Okay. You are on the right track. Okay. So you made a right statement. It's all right from the business, and it's always make sure you provision the resources via infrastructure as a code. And wherever you can automate, please automate, make your life easy. And there's a multiple way to do it. As you said, you can use a tool of your choice or for your organization need, but keep it consistent. If you are adding more tools for the same use cases, that became challenges. But as you said, each tool has a different pros and cons. You can adapt to the changes.
Awesome. And with that, let's end this first part of the session with what are we going to talk about next? So we're not going to release this on the same day. So what's the next part that we're going to talk about?
And next part is a fun part. Okay, we are going to go dive into some cool demo where how we provision the pipeline, the complete ML life cycle at the high level, how the CI/CD works. Okay, and we use a default AWS given option, and we will go much deep into it. Okay, it's a fun part.
CI/CD in this case means the CI/CD for the machine learning parts of the application.
Exactly.
Because we are going to start the second session with the infrastructure that we require to run this is already provisioned, and then we're going to look to that layer on top, right? So exactly. I'm looking really forward to that, AJ. Thank you so much. And with that, let's stop this recording and talk to you again in the next session.
Thank you.